Okay guys, so these are the notes that we started in class. These are the topic 2.1 and 2.2 notes for calculus. In class we started talking about how to approximate or how to find the equation of the tangent line. Well, in order to do that, we need to know what the slope of the line is, and we can't find the slope of a line right now with only one point. So we use secant lines, which essentially use 2 points on the curve, to approximate the tangent line. So we started by saying, okay, let's find the slope of a line that uses these 2 points. Then let's pick a point closer. Let's find the slope of the line between these 2 points. Let's pick a point even closer to the point that we care about. Let's find the slope of the line of those 2 points. And as the points get closer and closer together, the secant line is going to get closer and closer to the tangent line. So what we did is we said, okay, let's find the slope between these 2 points. Now let's find the slope between 2 points that are closer together. One and closer together, and we found that the slope of the secant line got closer and closer to 2, which in fact is the slope of the tangent line that goes through the point 1, 1 of y equals x squared. So then we just talked briefly and we said, okay, specifically for velocity, which is distance over time, the average velocity is the slope of a secant line. So if I drove, for instance, 6,000 miles in 10 hours, then my average velocity would be, oh wait, that doesn't make sense, I'm sorry. 600 miles in 10 hours, then my average velocity would be 60 miles per hour, right? That doesn't mean at every point I was going 60 miles per hour, but it does mean that over the course of the trip I was going that on average. So for instance, sometimes I might have been going 60 miles per hour, but I also might have gotten standstill traffic and then had to travel at 70 or 80 miles per hour at another time. Instantaneous velocity is my velocity at an exact time, right? So for instance, if I look at my speedometer, right? So for instance, like look at your speedometer. That'll give you your instantaneous velocity. So let's go on to the second problem. It says the position of a car is given by the values in the table. Find the average velocity for the time beginning when t equals 2 and lasting 3 seconds. So if we do t equals 2, we're going to have time 2, and at time 2, we're at 32 feet. So that's my position. And then 3 seconds later, we're at a time of 5. And at a time of 5, we have a position of 178 feet. So if I want to find my average velocity, I'm just going to do my slope. I'm going to do a difference in my function values over a difference in my time. And if I use my calculator and plug that in, I'm going to get a value of 48.667 feet per second. Okay. So 3 seconds apart. Now let's do only 2 seconds apart. So at 2 seconds, I'm at a position of 32 feet. At 4 seconds, which is 2 seconds later, I'm at a position of 119. We're going to do our average velocity. And if I plug that into my calculator, I'm going to get a value of 43.5 feet per second. Okay, let's do it again. 1 second away. We have 3 seconds. I'll be at a position of 70 feet. And values divided by the difference in my time, and that's going to give me 38 feet per second. So as I find my average velocities, as the interval of time gets smaller, it's getting closer to an approximation of what my instantaneous velocity is at 2 seconds, because this was our starting point for all of those. Number 3, if an arrow is shot upwards, its height in meters after t seconds is given by this, so its height, find the average velocity over the given time interval. So you'll notice as we look at these, the time intervals, these are intervals, not points, are getting smaller and closer together. So we're going to be approximating our instantaneous velocity. So let's do this. We need to find our point. So what we're doing is we're doing the function value at 2 minus the function value at 1, time 1, divided by 2 minus 1. Okay? So I'm going to plug these into my calculator. Sorry, this calculator is looking a little sad. So we're going to plug in 2. So I'm going to get 58 times 2 minus 0.83 times 2 squared. So that's my first h value. Oh, I hope that's an 8. Minus 58 times 1 minus 0.83 times 1 squared. It's all over 1. And I get 55.51. That's my instant or my average velocity. And we're doing it in meters per second. Okay. So now we're going to do the same thing here. We're going to do what's my function value at 1.5, what's my function value at 1 over 1.5 minus 1. And I'm going to let you guys plug this in yourself, and if you want to pause it and do it yourself, you can, but I'm just going to give you guys the values. We're going to do it again. We want to find the function value at 1.1 minus the function value at a time of 1. Okay, you plug that in. You get 56.257 meters per second. Okay, my intervals are getting closer together. I had a distance of 1 in time, half a second, 0.1 of a second. Now we're going to get even a little crazier. If you were to plug all that into your calculator, remember I'm just plugging in 1.01 into my function, then I'm plugging in 1 into my function. Okay. And then lastly, I've got this. So as my time values got closer and closer together, what did you notice about the average velocity? So it started increasing, and then it started leveling out at 56.339. So here it says find the instantaneous velocity after 1 second. So what we want to know is what's happening as this number gets closer and closer to 1. Well, as we get closer and closer to 1, this value I'm going to say is approaching 56 point, let's do 340 or 34 meters per second. We don't know for sure, but we have a pretty good guess based on the way that these are getting closer and closer to this value that this could be the instantaneous velocity. It's our limit, remember? What value are we approaching? So that's just an example of average velocity, instantaneous velocity. So let's go to the back and do a little bit with limits. So in class, we had already started this, so I'm just going to start where we were. Both first and fifth period, you guys got to almost the exact same place. So we said there's some strategies for finding limits. So I'm going to highlight this so you guys can see. Let's see the strategies for finding limits. We always want to just try to substitute in the value first, and that's what we did here. There's no reason we couldn't plug in 2. There wasn't a 0 in the denominator or something else crazy, taking the square root of a negative. If that doesn't work, we sometimes have to factor and cancel out a factor in the top and the bottom. That's what we did with number 2. We had an x minus 5 in the top and the bottom. That's a whole, but wholes don't impact limits because limits are what we're approaching, not the value of the function at that value. So that's why we did that here. Then sometimes we're going to do the rationalizing now. I think in one class we finished this problem and one we didn't, so I'm going to start with the half-finished one. This is where we started with. We said, let's find the limit as x approaches 0. But our big problem right now is we have a 0 in the denominator. So we're going to multiply by our conjugate, which is this plus this. And the reason we do our foiling, we're going to multiply these together. But then for the inner and the outer, so when we do these together and these together, we're going to get the same value, but one will be positive, one will be negative. So these are just going to cancel each other out. So then we're left with just these, this times this. So this times this gives me x plus 4. This times this gives me a 4, and then the signs are going to give me a minus. In the denominator, when you multiply these together, I highly, highly recommend that you do not distribute, and I will show you why. This 4 and this minus 4 are going to go away. And then you'll notice all we have left is an x over, and there's a factor of x in the denominator. So this is going to go away. So I'm left with just a 1 in my numerator. So I have 1 over the square root of x plus 4 plus 2. Well, now I can finally plug in my 0. And once we plug in the 0, we can get rid of the limit notation. So I plug in 0, and I get square root of 4, which is 2. 2 plus 2 is 4. 1 over 4 is 1/4. Okay, let's do another one. Let's find the limit as x approaches 0 of x squared plus 9 minus 3 all over x squared. Well, we can't plug in 0 because that's going to give us a 0 in the denominator. So let's multiply by our conjugate. The same FOILing thing is going to happen. We're going to take the first squared, and we're going to get an x squared plus 9 minus the back squared, which is going to give me 9, all over. We're going to have an x squared times this conjugate. We're going to have a plus 9 minus 9. So we are left with an x squared and an x squared factor at the bottom. So I'm left with just a 1 on top. Now we can plug in our 0. We plug in our 0, I'm going to get a 1 over square root of 9, which is 3 plus 3, which is equal to 1/6. Remember, I didn't get rid of that limit notation until I plugged in the 0. Okay, let's see if we can get through a little bit more. Number 5, I am going to draw us a picture. Let's see. I'm happy with my drawing. Okay, I want you guys to try these on your own first, but if you have, but maybe just pause it after I write them all down. So I want you to find the limit as x approaches -1 from the negative side. I want you to find the limit as x approaches -1 from the positive side. I should probably note that this is my function f of x in red. I want the limit as x approaches -1. I want the limit as x approaches 2 from the positive side. A few more. So pause the video, try them yourself. Okay. And then when you're ready, push play again. I'm just going to write in the answers, and you guys can ask me questions about these another time. The big one I want to touch base on is this f of 2. So the limit from both sides, we're approaching a y value of 0, but the function itself has a value of 2 at that point. Okay? Okay guys, I actually have to sneak out fast, but go ahead and just get through this video and I'll post a second video with these last two problems shortly, okay?